Hey guys, as always, I hope you guys are having a good day. Today, what we are going to do is we are going to take notes on 11.2. So we're actually going to go backwards. But this section is actually a little bit complicated in the sense that there's a lot that we need to take into consideration and remember about simplifying. So we're going to take some notes. Get ready. All right, let's go. All right, guys, we are going to take some notes on simplifying radicals. Now, with simplifying radicals, just like fractions and making sure that they are in simplest form, meaning that they don't have any common factors, radicals are similar. There are some rules that we want to follow, so we're going to go ahead and add this to our notes. All right, guys, if you're still following along with us, you can add that to your table of contents, so 11.2, which is simplifying radicals. All right, so here are our notes on 11.2. So we are going to be simplifying radicals. Like I said earlier, we want to just make sure that our radicals are in simplest form. And so these are the things that we're going to be looking out for. So the first thing that we want to make sure is that there are no perfect squares underneath the radical sign. The radical sign. So meaning that if we can take the square root of something, we are going to. For example, then, if we had something that looked like this, the square root of 25x, we know that we could take the square root of 25 and simplify that. So we want to make sure that we are watching for that. So it is going to be important to remember what perfect squares are. All right, so for those of you who don't remember what perfect squares are, I will help jog your memory. Perfect squares are your numbers such as 1, 1 times 1. They are 4, 2 times 2. 9, 3 times 3. 25, and so on. So again, those are your perfect squares. So we want to make sure that we know those numbers, and those are going to be important today as we simplify. All right, number 2, what we're looking for is that there are no fractions under the square root sign. So for example, if we had something like this, the square root of 1/4 to the x, we do not want this here. Just like I tell you guys that we don't want a decimal in a fraction, we don't want a fraction in a fraction, one of the rules here is that we do not want it underneath a radical sign. So get rid of that fraction. In the case of something like this, what we'll look at later, hopefully you guys remember, is that this is actually asking for the square root of 1 over the square root of 4, which you can simplify to 1 over 2, and then that square root of x is going to stay inside, and we'll talk about that later. But again, we want to work to get rid of fractions, so that is number 2. All right, our third rule for simplifying our radicals expressions is making sure that there is no radical or no square root in the denominator. And an example of that might look like this. We might have 1 over the square root of 6. So we would actually want to rewrite that because, again, you'll notice here that that square root is down there. So we'll talk about how we do that also. So these are things that we're going to be covering in our lesson today. So let's go. All right, one thing that you might see in your book is going to be what's called the product property of square roots. What this is just the rule of how we multiply square roots together. So let me go ahead and give you an example. Let's say we had the square root of 10 times the square root of 2. What you're going to do is you're going to multiply the things or the terms that are in the same place. So for example, 10 is underneath the square root, and 2 is underneath the square root. And so you would multiply those together. You would end up getting the square root of 20. For example, let's say I had 5 rad 2 times 4. All right, like I said, multiply the things that are in the same place. So for example, in this one, we have number, and neither of these numbers are under the square root. So that would be 5 times 4, which would be 20. And then under the square root, we have a 2. Notice there's no other square roots here, so we would just leave this as the square root of 2. So 20 rad 2. All right, let's look at another example. Let's say this time we have -3 square root x times, let's do 6 square root 2x. All right, so again, idea is the same. You are going to be multiplying the terms that are in the same position. So in this case, we have a -3 in the front and a positive 6. So we're going to multiply negative 3 and 6, which is going to give us negative 18. And then you are going to multiply underneath the square root. So here we have x underneath the square root, and here we have 2x. So when you multiply that, you should end up getting 2, and then x times x is x squared. And so again, that's how you're going to multiply your square root. So again, multiply the terms that are in the same position. Now, I'm going to tell you that's actually a little bit different than adding though. All right, so unlike multiplying, we were able to multiply essentially any numbers together. Here we had a 10 and a 2. Here we had an x and a 2x. Okay, with adding though, very similar to when we were adding our fractions and you had that common denominator, what we want to make sure is that adding square roots, only the same square root can be added together. So only the same square root can be combined. All right, and so what I mean by that is, for example, let's say we have 10 rad 2 plus 3 rad 2. Okay, notice here that we have rad 2 and we have rad 2. So here we have 10 rad 2s and here we have 3 rad 2s. So because they are the same radical value, we can combine them together. And so if I do that, this would give me 13 rad 2s. So again, combine the ones that are the same. Now, for example, let's say that we had instead negative 3 rad 5 plus rad 10 plus 6 rad 5. So again, we can only combine the ones that have the same radical value. So think of it kind of as a variable. Only combine the variables that are the same, only combine the radicals that are the same. So in this problem here, we have negative 3 rad 5 and we have positive 6 rad 5. So we could combine that. Negative 3 and positive 6 would give us a positive 3 rad 5. And then again, notice here though, this guy, rad 10, he's different. He is not the same, so we can't combine him. So what we would do is we would just put plus rad 10, and then that would be our simplified answer. So there's nothing else you can do here. And again, that's because our radical values are different. So we cannot combine these because they are not the same. So just be very careful. So again, 5 and 10, not the same radical value. And so what we want to do is first we want to remember our perfect squares. Those are numbers that you guys are going to be looking for. And so again, I will write them down as a helpful reminder, but those are your numbers such as 1. And so on. So again, think about those perfect squares. Now, to simplify a square root, what we're going to be looking for, you always want to think, okay, what perfect square goes into that number? So, for example, the square root of 25 is easy because that is a number that you guys know automatically is a perfect square. We know that the square root of 25 is 5 because it can be 5 times 5, and then we talked about that plus or minus. But again, today, only go with just the positive values. Okay, now let's go ahead and let's take a look at something that is not a perfect square. Square root of 75. Now, 75 is not a perfect square. There is no number times itself that would give us 75. But the idea of simplifying means that we're going to break up our radical and we're going to rewrite it as a simplified expression. What that means is you're going to break up the number 75 and you're going to figure out what perfect square goes into 75. Now, what you can do is kind of go through the list. Okay, I know 1 goes in there. 4 doesn't divide in evenly. 9 doesn't divide in evenly. 16 doesn't divide in evenly. Oh, 25 does. 25 goes into 75 3 times. So we kind of make that factor tree. 25 and 3 multiply to 75. All right, we know that 25 is a perfect square. And because, again, this problem is a square root problem, we can say the square root of 25 is 5. 3, do we know the square root of 3? Hopefully you would say no, and we don't. So what that means for 3 is going to stay in the square root jail. And this is what's called a simplified radical. So it would actually have the same value. If you were to calculate the square root of 75, it would be equal to the square root of 3 times 5. So it's the same value, again, just in that simplified form. And so that's what we want to be doing. So we'll go ahead and try a couple more to see if that makes sense. Okay, so same idea here. We know that 45 is not a perfect square. However, we are going to be looking for numbers that go into 45 that are perfect squares. So does 1 go in? Does 9 go in? Does 25 go in? Does 100 go in? And so hopefully you can figure out that split. In this case, your perfect square would be 9 and 5. All right, remember the problem is a square root problem, so we're really taking the square root of these numbers that we just found. I like to circle it so I know which number I'm taking the square root of. Square root of 9 is going to be 3. All right, and then you ask yourself, do we know the square root of 5? The answer is no. So 5 is going to stay inside the square root jail. And then same thing with x. Do we know the square root of x? And the answer is no. So again, x also stays inside that square root jail. All right, I'm going to have you guys try too, and we'll see if you can get that answer. All right, here are your 2 problems. Go ahead and try them. All right, let's see how you did. So I'm going to go ahead and go through these problems. So for the first problem here, the square root of 32. Now, you're looking for a perfect square that goes into 32. One thing that I failed to mention though is you're actually going to be looking for the largest perfect square that goes into 32, which in this case is going to be 16. And then so 16 times 2 gives us 32. Remember, we're taking the square root of 16, which is 4. 2 does not have a perfect square, so we're going to leave that in square root jail. And then likewise, don't forget that x that's right here also, so 2x. Now, if you did not pick 16 as your perfect square, that is okay. Let me show you what you can do about that. So same numbers here. It was 32x. So let's say with 32, you instead picked 4 and 8. You would be correct because 4 is a perfect square. So the square root of 4 we know is 2. That would leave us with the 8 here, and then again that x that's on top. Now, with this problem though, what's happening is that 8 could actually be simplified one more time. Again, think of those perfect squares. 4 goes into 8 still. So you could do 4 and 2. 4 is your perfect square. Now, when you take the square root of that 4, we know it's 2. Don't forget though that you had this 2 that you already took out, so that actually comes down 2. And then inside we have rad 2 and then x. Now, when this number is outside like this, these numbers get multiplied together. Remember, anything that's next to each other is being multiplied. So 2 times 2 is 4. And then rad 2x. So you'll see that it's the same answer that we have right here. So it is going to be beneficial though just to look for, again, the highest perfect square that goes into that number. So that same idea actually with this one, with 500. You could say that 25 goes into 500, and it does. Again, but the largest perfect square that goes into 500 is actually going to be 100. So 100 times 5. All right, the square root of 100 is 10. We don't know the square root of 5, so we're going to put that in square root jail. Now, one thing, though, that is a little bit new here is actually this one. Notice I threw in a square variable here. The square root of x squared is actually x, because if you remember, it's x times x. And so in this case, you would actually pull it out. And that is the next thing that we're going to take a look at, is how do you take the square root of a variable? All right, guys, here's our next section. So it's taking the square root of variables. So in our first example, let's go ahead and just take a look at the square root of x. We actually saw in our last example that we can't take the square root of x, so it actually just stays as is, square root of x. Now, though, we are going to start to see some variables that have exponents on it. X to the second we saw. Square root of x to the second is actually just x. Square root of x to the fourth is actually x squared. Square root of x to the sixth is x to the third. Do you guys see any patterns there? Hopefully you're noticing that it's half. Half of 2 is 1, half of 4 is 2, half of 6 is 3. So the square root of an even exponent is actually easy. You're always just going to be taking half. All right, if you want to think of the reasoning behind this, though, is let's go ahead and look at this one. We can say that this is x to the third times x to the third. And remember, the square root is always asking what number times itself gives us this value here. If you remember back to your exponent rules, this means I have 3, and then this means I have 3, which is that total of 6. So you're, again, going to be dividing by 2 here for all the even exponents. All right, the question then becomes, though, well, what happens if my exponent is not even? And that is a simple fix. So let's say we have x to the fifth. So just like we did with our numbers, you are actually going to be looking to break this down a little bit. So x to the fifth, I'm actually going to break this down into x to the fourth. So I'm breaking it down to an even exponent. So I bumped it down one number. And then x to the first. So hopefully you guys would agree that if I have 4 x's and 1 x, that would give me 5 here. Just like before, with the even exponent, we can take the square root of that. So x to the second, because remember we take half, and then rad x. All right, so let's try that again in case that did not make sense to you. So again, with an odd exponent, let's say we have the square root of, we're actually going to do 2 here, y to the 20th, and let's do x to the 15th, okay? Now, y to the 20th, again, I like to circle the perfect square ones, the ones I know the square root of already. We know it's an even exponent, so we're going to take half, which is going to be y to the 10th. All right, but notice those x's. Those x's right here have an odd exponent, and we can't just split it in half, so we have to break it down. Remember, when we break it down, bump it down one number to an even number. So x to the 14th, so I have 14 x's here, and then x to the first, because 14 x's and 1 x would give me 15. All right, here's that even exponent again. We know that the square root of an even exponent is half, so x to the 7th. And then here, we do not know the square root of x, so we are going to leave him as rad x. And so this would be our final answer here. So again, I know there is a lot of rules here, so you guys have to kind of just follow along and then ask questions though if it does not make sense. All right, so I'm going to write down these rules again for you. So remember, if you have an even exponent, you take half of it. So again, take half. If you have an odd exponent, you are going to bump it down. So bump it down to an even number, and then plus 1, just like we saw with our x's right there. Okay, so I'm going to give you guys an example to try. It will have both a number to simplify and it will have some variables to simplify. Here is your problem. All right, so again, you have a number that needs to be simplified. You have an odd exponent and you have an even exponent. Go. All right, here is your answer. Did you get it? Thumbs up. All right, so let me go ahead and explain it. So 63 here, again, I split that into 9 and 7. 9, again, I circled my perfect square, which was 3, so I pulled it out. And then I made my 7 and I left him in square root jail. All right, don't be tricked here. Remember, exponents have a different rule. You are always looking for half of it. Because this is an odd exponent, I bumped it down 1 to x to the 8th and x. I circled this because, again, I know that I could take the square root of an even exponent, which is half, so x to the 4th. And then, again, x stays here. And then y to the 12th is an even exponent, so I'm going to take half, and that's going to be y to the 6th. So that is my simplified expression there. So you guys might have to do a little bit of practicing, but use these examples to help you. All right, let's continue on. We just talked about the first rule with our simplifying of radicals, making sure that there are no perfect squares under the radical sign. So we talked about simplifying a number that's not a perfect square, and we talked about simplifying variables that are underneath the radical sign. This is actually going to be number 2. So rule number 2 was working with fractions under a square root sign, and that's where this word quotient comes in from. So if you guys remember, quotient meaning divide. So an example of this might be the square root of 16 over 25. All right, so with a square root of fraction, what it's telling us to do is actually to take the square root of both the numerator and the denominator. So this would be taking the square root of 16 over the square root of 25, which would simplify down to 4 over 5. And again, this time we are actually only going to be taking the positive value, so you do not have to worry about that plus minus on these problems. All right, let's take a look at another one. Let's say that we had this, the square root of the fraction 13 over 100. Okay, so same thing, break it down. On the top, the square root of 13 over, on the bottom, the square root of 100. Would simplify to 10 on the bottom. And then take a look at here. Notice that the square root of 13 is not a perfect square. Think to yourself, can I simplify this? Meaning, are there any numbers that I know that would go into this that I can take the square root of? So those numbers like 9, 25, 16. The answer is no. This cannot be simplified. So in that case, you would just leave it the square root of 13. All right, so not too bad with that second rule. Just make sure that if you do have a fraction, you are taking the square root of both the top and the bottom number. All right, and now for rule number 3. This is what's called rationalizing the denominator. At the beginning of our notes, I said one of the rules was that you cannot have a radical in your denominator. So, for example, let's say we were simplifying this. The square root of 100 over 7. Okay, we know how to do that. Square root of 100 on the top over the square root of 7 on the bottom. This would give us 10 on the top, and then square root of 7 we don't know, so we would leave it rad 7. Okay, but here is the issue though. The third rule said that we cannot have a square root in the denominator. And so we have to get rid of that. And that's actually what rationalizing is. Rationalizing is going to help us get rid of the square root on the bottom. So I'm going to show you how you do that. All right, so to rationalize the denominator, I'm actually going to be multiplying here. I'm going to multiply by rad 7 over rad 7. Why I chose this is because rad 7 over rad 7, hopefully you guys will realize cancel each other out and is equal to 1. So by multiplying by this, I'm actually not changing the value of this problem here. But by multiplying by rad 7 over rad 7, it is going to help me get rid of the denominator that has a radical. And I'll show you what I mean. So let's go ahead and just like we do with fractions, we're going to multiply straight across. So 10 times rad 7. Remember, multiply the terms that are in the same places. So here there's a 10. And I guess in front here you can say there's that invisible 1. 10 times 1 is still going to be 10. You have no other radical you're multiplying by here, so you're going to keep that rad 7. And then denominator. Now, rad 7 times rad 7. Multiply the terms that are in the same place. Underneath the radical, we have 7 times 7, which is 49. And then I'm going to ask you guys this. Is there anything unique about the square root of 49? And hopefully you'll see that it is a perfect square. So you can actually simplify this then into 10 rad 7 here over, and this is the part that's being simplified. That's going to simplify down to 7. And here is your final answer. So you'll see that by rationalizing here and multiplying it by this radical, it ends up canceling out the radical. So that, again, we can follow that rule and make sure that there are no radicals in our denominator. So let's take a look at that one more time, though, just to make sure that makes sense to you guys. All right, so here's our example. We have rad 2 over rad 3x. So currently we are breaking that third rule because we have a square root in our denominator. So we're going to get rid of that, just like we did in our last example. We're going to rationalize it. So we're going to multiply to get rid of that. Here, what do you guys think we'll multiply by? In the last example, we did rad 7 over rad 7. And we did rad 7 because the denominator here was rad 7. So here, you are going to multiply by rad 3x over rad 3x. And again, remember, this won't change the value because we're really just multiplying by 1. But this is going to allow us to cancel out that square root term. Okay, on top, again, multiply the terms that are in the same place. So these are both under the radical sign. So 2 and 3 would give me 6. Keep that x. And then on the bottom here, I have rad 3 times rad 3. So that's going to be 9. And then x squared, which would simplify then to rad 6x on top over 3x. Now, if you notice that the rad times rad here cancels the radical sign out, you can just go ahead and write 3x without having to do this step. But in the case that you don't see it, then you might want to multiply and then take the square root so you can understand how we got that answer. But here, this would be your final answer. And again, that is with a rationalized denominator at the bottom. I'm sorry, I just want to make sure that you have all the notes that you need. But I'm going to leave here 2 last problems for you to try if you kind of want to make sure that you have all these different rules down. This is going to kind of combine the skills without being separated. So see if you understand what to do. Here are your examples. All right, guys, so here are your 2 examples. Like I said, they have a mixture of the skills that we just went over. So try your best, see if that makes sense, see if you can simplify correctly. All right, go. All right, guys, how did you do with those? So for the first one here, what's happening is you're distributing this rad 5 to both terms. Remember, multiply the terms that are in the same place. This becomes rad 50, but it does need to be simplified, so you would look to break that down. Remember, when you pull out a perfect square here that is 5, that number gets multiplied by what's on the outside, so that's how I end up with this 40. And then be careful here, these are not like terms, so you're going to leave them as is. All right, our second one was actually a little bit more challenging, so I'm going to talk about that one as our last thing. So we do want to break up these fractions, and then you would multiply. Okay, please note here when I did rad 3 times rad 6, I got rad 18. All right, you can multiply everything by rad 18, so to rationalize the denominator. I actually simplified it first, just because it lets me work with smaller numbers. So I simplified mine, said this 9 and 3, square root of 9 was, 9 and 2, square root of 9 is 3, and then I rationalized it here. All right, once I rationalized it, I end up getting this, 2 rad 2 over 6, and that would be your final answer. Now, to complicate things and just to be as accurate as I can, you could actually simplify this because if I were to cover up this radical right here, you want to think of these numbers in the front as a fraction. You could simplify that. Final actual answer would simplify down to 1 rad 2 over 3. And again, that is just being technical here. If you gave me something like this, you are correct. But again, in just perfect simplified form, this is what we're going to look at. So you won't have anything quite as complex on your homework, but again, those are your steps just to make sure that you have those skills down. So try your best. Let me know if you guys need help. All right. All right, guys, that's it for our lesson for today. Hopefully that made sense, and hopefully you guys feel pretty good about the lessons. If not, as always, email me, let me know. You guys can comment down below, let me know maybe what works best for you guys as well. But that's it for this week. Tune in again next week. We have a couple special guests, so come check them out. All right, I'll see you guys later. Bye, guys. All right, bonus problem just in case you actually need this one for the homework. So I just wanted to make sure that I covered everything for you guys. Okay, really quickly, what I want to remind you about this problem here is that you have a square term here. Please remember that means to expand your problem. So this problem is really 2 rad 3 plus 5 times 2 rad 3 plus 5. So you are going to use double distributive to solve this. Take your 2 rad 3 and you're going to distribute it. 2 rad 3. Remember, multiply terms that are in the same place. So 2 and 2 in the front is going to give you 4. Rad 3 and rad 3, so they're both underneath the radical, would give me rad 9. Alright, 2 rad 3 times 5. 2 and 5 are a whole number, so 2 times 5 is 10. And then that rad 3 is added on there. It is a positive, so we're going to denote that with a plus sign. Alright, do the same for your second term. You have that 5. 5 times 2 rad 3, so 5 and 2 are your whole number, so that's 10. And then there's that rad 3 again. And then 5 times 5 is going to be 25, and it is positive, so we're going to put that plus sign there. All right, just like we did when we multiplied our two binomials, combine like terms here. So this is 4 rad 9 plus, and I have a common rad 3 here, so I have 10 and 10, so it's going to give me 20 rad 3, and then plus 25. All right, last thing though to look out for though, is there anything else that you can simplify? Hopefully you said yes, so it's actually right here. Remember, this rad 9 here is actually the same as 3, so this problem is really the same as 4 times 3 plus 20 rad 3 plus 25. Final answer that you are going to get then is going to be 12 plus 20 rad 3 plus 25. Combine your like terms here. And then final answer is going to be 20 rad 3 and then plus 37. All right, and the order that you write that is not going to be too important. Typically, you are going to see radicals first, but either of those would be correct as long as your signs are there. All right, guys, that is it for reals this time.